Okay, all right, started recording. So we started off functions yesterday. Just to quickly recap what all we did. We went over what domain and range is. Range is always a bit of a pain to calculate. That's how it is. But domain is fairly easy. All you have to do, watch out is for a few rules, right? You cannot have square root of a negative number, right? So that's a violation. You cannot have log of a number. This number cannot be 0 or negative. And then in the denominator, suppose you have something, the denominator cannot be 0. So these are the main ones that you need to be aware of, and that will help you determine what the domain is. And range ke liye, you have to be a little careful. There's no set method as such. One thing for sure is you should try the extreme ends of the domain. That's for sure. And then, but it might be that something is getting violated in between the two extremes of the domain. So just because the domain is, for example, I'm just making up something, right? Just because the domain is from -20 to +30, it doesn't mean that your range will correspond to whatever restriction you have at -20 and whatever restriction you have for +30. That won't be the corresponding range, right? So what I mean is this won't be the range necessarily, right? So for a simple example, suppose I have a simple example, right? Let's say I have x and y like this. Right? At let's say this is -20 and this is at 30. Let's say the function goes from here and goes like this. So let's say this point is -20, 10. And let's say this point is 30, 20. Okay. So just because the domain is between -20 to 30, it doesn't mean the range is between 10 to 20, right? So 10 is the y value here, 20 is the y value here. So it'll be wrong to say the range is between 10 and 20, when in fact it's going high up here, right? So you'll have to watch, you have to get a sense for how the function itself looks like, which is why to determine the range, it's always good to sketch the graph. Okay. So on that note, we also went over how to sketch a graph. So in any sketching, you'll have to be aware of 3 or 4 things, right? What is the x-intercept? What is the y-intercept? Similarly, what is the horizontal asymptote and what is the vertical asymptote? Vertical asymptote generally happens when the denominator is threatening to become 0. On either side of it, will there be an asymptote? Horizontal asymptote is the behavior when x tends to infinity and the behavior when x tends to -infinity. There are also asymptotes which are, what is the name? I am forgetting the name, but which is neither horizontal nor vertical. So you can have asymptote, for example, a graph can be, for example, the graph can be something like this. So far out, it can approach a line just like this, right? So this could be the asymptotic line, right? So it's neither horizontal nor vertical, but far out, it's approaching that line. So, but anyway, that's not there for you, but just be aware that asymptotes need not just be horizontal and vertical. They can be lines at a slope as well. Okay, all right. And then, so for example, a simple problem on sketching, what did we do? So suppose we had a function like 3x plus 2, 3x plus 2 upon x minus 5. Okay, so we said wherever the numerator becomes 0, that's the x-intercept. Wherever x is 0, that's where it cuts the y-axis. That gives you the y-intercept. And then wherever the denominator is becoming 0, in this case x equal to 5, that will be the vertical intercept, vertical asymptote, I'm sorry. And then the last one is the horizontal asymptote. So far out. Okay, maybe I'll just take a minute to just go over the sketching once more. It's probably worth it, right? So let's take this example itself, 3x plus 2 by x minus 5. Okay. So let's draw the coordinates again. Let's say this is the x and this is the y. We'll do it quickly this time. Okay. So what are the key points? It passes through when the numerator is 0, when x is -2 by 3. So -2 by 3, 0 would be the x-intercept. When x is 0, the y value is 0 plus 2 by 0 minus 5, minus 2 by 5. So let's say somewhere here. And then when x is 5 is when the denominator is threatening to become 0, which is not allowed. So at x equal to 5, you would draw a vertical asymptote, something like this. So this is a vertical asymptote, x equal to 5. So on either side of 5, it's going to approach infinity. And then you can check, is it approaching infinity towards the positive infinity or towards the negative infinity? For example, if x is slightly more than 5, the denominator is a slight positive quantity, right? And therefore, it'll approach positive infinity to the right of 5, right? Whereas if x is slightly less than 5, the denominator is a small negative quantity. Therefore, it'll approach, the whole fraction will approach a small, it'll approach negative infinity. Note that the numerator in this case is throughout positive. When x is 5, the numerator is of x is around 5. The numerator is going to be around 17, but slightly around 17 does not really matter the actual value. The denominator is what is going to really tilt the table. Okay, so now we have the x-intercepts, you have the vertical asymptote. The last one is the horizontal asymptote. The one easy way to find the horizontal asymptote is what is the coefficient of the highest power of x in the numerator. So that is 3 here. 3 is the highest power. 3 is the coefficient of the highest power of x. In this case, the highest power of x is only x power 1. Even in the denominator, the highest power is only x power 1, and the coefficient happens to be 1. So 3 by 1 would be the horizontal asymptote. And it's easy to see. Why is this coming from? Suppose I have 3x plus 2 by x minus 5, right? The 2 and 5 are not going to change with x. Whereas x can go up to 100,000 million zillion, right? So if it's 3 zillion plus 2, it's approximately 3 zillion anyway. And with the 1 zillion minus 5, it's approximately 1 zillion anyway. So which is why what matters is really this coefficient and this coefficient. Okay. And therefore, the ratio is 3 by 1. Yeah, Dave, just 1 second. Okay, all right. Ask your question, Dave. Yeah.
If there's x square on top, then it becomes.
Yeah, actually, so that's a good point. So suppose 2x square minus 3x plus 7 upon minus 5x square plus 100x minus 13, let's say. Then the highest coefficient, the highest power of x in the numerator and denominator is both x square, and therefore it's the simple ratio 2 by minus 5 or minus 2 by 5. But what probably he's indicating is the highest power of x need not be the same in the numerator and denominator. For example, in the numerator, let's say it's x is the highest power, right? Let's say it's 100x plus 32, and the denominator is 2x square minus 10x plus 11, something. Then the highest power is only x power 1. The highest power is x power 2 here. The denominator power is higher. As soon as the denominator power is higher, the asymptote will become 0. The asymptote, the horizontal asymptote will become 0, right? And again, why is that? So we all agree that the leading term is what is going to matter most. For example, the 32 is always 32, whereas x can go gradually up from 1 to 10 to 100 to 10,000. So very slowly but surely 100x will start to dominate. The 32 would not matter. Similarly, in the denominator, even though it's 2x square minus 10x plus 11, even for a small value of x like 100, let's say this is already 20,000, whereas this is only 1,000 and this is always 11 only. So what will matter will be only the 100x in the numerator, the dominating term, and the dominating term in the denominator will only be the 2x square, right? Now, when this ratio is taken, the x and x will get cancelled. So we have 100 upon 2x. But remember, the bottom can go up to whatever you want, right? If x is a zillion, the numerator is only 100 after the cancellation. And therefore, this is going to approach 0. So in other words, to summarize, if the numerator and denominator have the same highest power of x, then the ratio of the two coefficients is the horizontal asymptote. However, if the denominator has a higher power of x, no matter what the coefficient is, doesn't matter, right? Whether this can be as small as 2, this coefficient can be as big as 10,000, doesn't matter. But as long as the highest power of x is larger in the denominator, the horizontal asymptote will be 0, namely the x-axis will be the horizontal asymptote. So horizontal asymptote is always y equal to a constant. Just like a vertical asymptote is x equal to a constant. So in this case, the vertical asymptote is x equal to 5. So vertical asymptote. Similarly, the horizontal asymptote will be y equal to a constant. So back to this question, like 3x plus 2 by x minus 5, we agreed the ratio is 3 upon 1, which is 3. So the horizontal asymptote will be at 3. So let's say I'll just put a horizontal line at 3. So this is the horizontal asymptote. And based on other hints, we can see, right? So clearly it's going to go like this. And here we have it passed through this point and this point. So we can complete more or less using this. And then we can complete it more or less using this. Right? So if you once you sketch the graph, you can easily tell what the range is in this case. And the range is minus infinity, less than y, less than infinity. All the values are possible, except y cannot be 3 in this case, right? It can never touch this horizontal asymptote, right? So y cannot be 3. Does it make sense? Thais, are you good with me completely on this? Sarah?
Yes, sir.
Yeah. Dave, one more question. Go ahead, please.
Yeah, sir, I'm just not clear. If it's x square and in the numerator and x in the denominator, then it's just the coefficient of x square.
Okay, so I didn't cover that part. If the numerator is higher, okay, so let's consider 3 cases. So if the numerator and denominator have the same, so I'll just say this is numerator and this is denominator, right? Okay, so if, okay, let's say the highest power is, how shall I say this? Okay, I just want to draw a grid. Okay, so fine, ignore the grid. I'll just do it here separately. If numerator equal to denominator, by this I mean the highest power of x, highest power of x, right? Then this implies it's just the ratio of the coefficients of those highest power. Okay, if the numerator is less than the denominator, as in this example, here it's 100x upon 2x square, right? I'm ignoring the other terms. X power 1 versus x power 2. So the numerator is less than the denominator. Then the horizontal asymptote is y equal to 0. So the horizontal asymptote in this case will be y equal to whatever the a by b. Let's say a is the coefficient of the numerator highest power, b is the coefficient of the denominator highest power. There will be y equal to a by b. So here, in the second case, the horizontal asymptote is y equal to 0. In a way, you can imagine that this is 0x square plus 100x. And now you can say the highest coefficient is 0. The highest coefficient is 2. Therefore, 0 by 2, which is 0. Does it make sense, Dave? Yeah, Dave?
Yes.
Okay, now what you're asking is the numerator greater than denominator. In this case, there is no horizontal asymptote at all. In fact, the graph will go towards infinity or go towards minus infinity. For example, if you have a case like 2x square minus 10 upon 100x plus 100,000, right? So for small values of x, the denominator is going to be bigger. But then as x becomes bigger and bigger and bigger, let's say x is 1,000,000. So this is 2 into 10 power 6 whole power 2, which is 2 into 10 power 12, right? And the denominator is 100 into 10 power 6, which is 10 power 8. And this guy is very, very small, right? Only 10 power 5. So practically, it's going to be the 10 power 12 and the 10 power 8 competing, which is 10 power 4, which is essentially infinity, right? So there won't be any horizontal asymptote at all. The graph will be approaching infinity. So it'll go zoop like this. Does it make sense, Dave? Sumer, you're with me completely on all of this?
Yes, sir.
Okay, cool. Amit, welcome back. Did you catch up on the last videos, Amit?
Yeah.
Okay, all right. Sorry for the family loss again. And yeah, welcome back again. Okay, so then yesterday we did domain range and we did sketching. And then we did composite function f of g of x. And we saw how the domain can get affected if you have a composite function. I won't repeat again. When you do the homework problems, I'm sure all these confusions will come and then we'll discuss as part of the homework. And then finally, we did the inverse, right? So given any function, how to find inverse by swapping x and y, and then rewriting y in terms of x back again. Okay, all right. So today we have a few things. We'll start with partial fractions. So what is partial fractions? partial fractions will come in handy later when we do integration. It'll come in handy, but the concept is very easy. So let's say I have 2x plus, okay, I'll write 2x square plus, let's say, let me make up some good question, 7x plus 10, 5, okay. Okay, and let's say in the denominator, we have minus 3x plus 2. Okay, now the challenge is, can we write it as a by some linear function? Linear means it has only x, not plus b by some other linear function. If you're able to do it, it helps in further steps, right? For example, in calculus, there's something called integration. Some of you might have already studied it. So when you have to integrate something like this, it becomes difficult in this form. But if you're able to split it as a partial fraction, it becomes easy. But for now, ignore all of this, right? Our goal is, can we write it as a by some linear, by b by some. So the first order of business is factorize the denominator. So let's factorize this. So 2 times 5 is 10. So finding two numbers that multiply to 10, right? And add to 7. That's how we factorize, right? Very often people forget the 2, right? The multiplication should be the product of the constant term and the x square term. So the product should be 10. The sum should be 7. So it's 5 and 2. So 2x square plus 2x plus 5x plus 5. So it happens to be 2x into x plus 1 times, plus 5 into x plus 1. So it's 2x plus 5 times x plus 1. Okay, so I will write it as a by 2x plus 5. It's the reverse process of taking a common denominator, right? Plus b by x plus 1. So suppose we had whatever I have on the right hand side, suppose we had that, then we could have taken common denominator by multiplying 2x plus 5 and x plus 1, right? So in a way, it's the reverse process, what we're doing right now, right? And suppose we do the multiplication, then what will happen? 2x plus 5 times x plus 1 will get multiplied here, which is exactly the denominator we have here. Now it will become, the numerator will become a times x plus 1 plus b times 2x plus 5, right? So if you collect all the x terms, so it's x into a plus 2b. Okay, and the constant term is what? Is just a plus 1a plus 5b. 1a plus 5b. Okay, and now the denominator is whatever this is, right? And now all I have to do is match minus 3x plus 2 with this, right? And that's easy to do by comparing coefficients, which means my a plus 2b must match my minus 3, and my a plus 5b must match my constant term, right? Which is 2 in this case. So this is the constant term, right? So that must match my 2. And now we can simultaneously solve this very easily. Let's say I subtract, I have minus 3b equal to minus 5. So in case I do some silly mistake, please catch me, guys. Okay, so I'm just doing it very casually. So b is 5 by 3. And then we can put back that b somewhere here. Let's say I put it in the first one. I can solve for a. So I have a equal to minus 3 minus 2b, 2 times 5 by 3. Okay, and then I can simplify this, right? Minus 9 minus 10 by 3. It doesn't matter. All of you know how to do this. Minus 19 by 3. So in summary, if I didn't do any silly mistake, I've split it into minus 19 by 3 times 2x plus 5 plus 5 by 3 upon x plus 1. Now, the further steps in this problem, for example, integration becomes much easier once we split into this partial fraction. But this concept of splitting into two linear parts in the denominator is called partial fractions. Okay, that's all I have to say on partial fractions at this point. Okay, yeah, Thais, question?
I'm just sorry, I didn't catch how you found a plus 2b equals to minus 3.
Oh, okay, because I tried to match this numerator. The original question, the numerator was what? Minus 3x plus 2. So it was minus 3x plus 2 in the numerator. So the x term is minus 3. The x coefficient is minus 3. X coefficient is a plus 2b.
Okay, thank you.
Right, and the constant term likewise, a plus 5b and 2. Okay, all right. Sure, no problem. So the next one is remainder theorem and factor theorem.
So I have a doubt.
Yes.
Can you just explain how you got a plus 2b and a plus 5b?
Oh, so I cross multiplied. So a into x plus 1 plus b into 2x plus 5. Correct? So that part is clear, right? So when I expand this, what do I get? I get ax plus a plus 2bx plus 5b, right?
Okay, and then you just
And then I compare the add all the x terms and add all the constant terms.
okay. Yeah, thanks.
Sure. Okay. So next I will go to a synthetic division. And so basically the normal division versus synthetic division. So for example, suppose I have 2x square minus, or let's say 2x cubed minus 7x square minus 11x plus 20. Okay. And suppose I have to divide it by x minus 3. Okay. So the normal division is the normal division is a long division. So x and 2x cubed. So it's the ratio is 2x square. So I'll just go through the process, even though all of you know this. So it's 2x square, and here it's minus 2x cubed, I'm sorry, minus 6x square. I subtract. So it's minus x square, and then bring the minus 11x and bring the plus 20. Okay, and then minus x square when divided by x will give minus x. So minus x times x is just minus x square. Minus x times minus 3 is plus 3x. Okay, so subtract. So it's minus 14x, and the 20 comes through. And then last step, minus 14. So it's minus 14x plus 42. So the remainder is minus 22. So this is how we'll finish the long division, right? Now, equivalent way of dividing is called a synthetic division, which is much faster. Suppose the same problem is given, then all we have to do is write down the coefficients alone. So it's 2x cubed minus 7x square minus 11x and then plus 20. And then in the division, we put it like this, right? And then what causes this to become 0? X equal to 3 will cause this to become 0. So I'll put the number 3 here instead of x minus 3. So it's only numbers. There's no x at all anywhere. Okay. So, and then we start off by putting a 0 here. And then it's just a constant addition, multiplication. What do I mean by that? First you add 2 plus 0 is 2. Now you multiply the 3 with the 2. So 3 times 2 is 6. Now add again. So always addition here. And the multiplication is always with this, right? So minus 7 plus 6 is minus 1. Okay. And then 3 times minus 1 is minus 3. Now add again. Minus 11 plus minus 3 is minus 14. Now multiply. 3 times minus 14 is minus 42. But if you're able to see the left side, you're able to recognize these numbers, minus 22, right? So the last one that comes here, that's the remainder. Okay. Now, and this guy is the quotient. So what do you mean 2 minus 1 and 14? Obviously, we'll have to replace with x square, x and 1 constant term. How do we know it's x square, x and constant term? Because we started off with 2x cubed and then we divided by x minus 3. So it's a cubic divided by a linear. So it's a cubic divided by x power 1. So the quotient has to be a quadratic, right? A third power divided by a first power, it will give a second power, right? So we know it's 2x square, and then this gives you the coefficient, right? Minus 1x minus 14. So that's the quotient. And that's exactly the quotient that we got here also. 2x square minus x minus 14. And this is the exact remainder we got here, minus 22. We got the exact remainder here. Okay. All good?
I have a question.
Yes, Abhya, go ahead, please.
Oh, shouldn't you be putting minus 3 instead of 3?
No, we should put whatever causes x minus 3 to become 0.
Okay.
So it's 3. So had it been x plus 2, then we would have put minus 2 in the division. Okay, the synthetic division. Okay, now what is this remainder theorem and factor theorem telling? Okay, the remainder theorem is, okay.
So is that always going to be 0? Like in what you just did below minus 2, will that always be 0?
Yes, the first step will always be 0. Correct. The very first step will always be 0. Good question there. Okay, so what is the Sumer, understood, right? Always 0. Yeah. So remainder theorem and factor theorem are related. In fact, the factor theorem is a special case of remainder theorem. So I'll first cover remainder theorem. So the remainder theorem says, suppose I have some polynomial x cubed minus 5x square plus 2x minus 17. Okay. And suppose I'm dividing it by x minus 2. Okay. And suppose I don't care what the quotient is, then I can avoid myself all the trouble of dividing, be it long division or synthetic division. Suppose my focus is only on the remainder, right? The remainder is, so let's say this is f of x, right? I'm dividing f of x by some divisor. Let's say this is a divisor, right? D of x, right? And then ideally we'll get a quotient here, and then we'll do all of this division, and then finally we'll get a remainder here. Okay, remainder is here. Okay, now now if I have to write it out like this, so what? Let's do a simple math division with just numbers. Suppose I have 71 divided by I don't know, let's say 13. 13. Okay, so 13 5s are 65. The remainder is 6. So how do we connect all of these numbers? We say our 71 is nothing but 13 times 5. The divisor, this is the divisor, this is the quotient, and this is the remainder. So the 71 is nothing but the divisor times the quotient plus the remainder, right? So 65 plus 6. Exactly same thing. F of x is, right? F of x is the product of the quotient and the divisor. So q of x into d of x plus the remainder, right? Okay, so in this example, so x cubed minus 5x square plus 2x minus 17 is nothing but the quotient q of x times the divisor, which is x minus 2, plus the remainder. And suppose I don't care what the quotient is, my aim is to find only the remainder, then it's easy. How do we do it? We can put x equal to 2. If you put x equal to 2, right, in the left-hand side and right-hand side, we get q of x into 2 minus 2, which is 0, plus the remainder. In other words, the function evaluated at 2 is the remainder itself, right? So f of 2 is the remainder. And in this case, it's just a cubic, but just imagine it's a 5th order. Then there's a lot more terms, right? But if the game is only to find the remainder, it's very quick. So f of 2 is just 2 cubed minus 5 into 2 square plus 2 into 2 minus 17, which you can do even by hand, right? 8 minus 20 plus 4 minus 17. So how much is this? 12 minus 20 is minus 8 minus 25. So the remainder is minus 25, right? In a jiffy, I can find what the remainder is. So to summarize, if I have f of x and I divide by some d of x, which is the divisor, right? Or rather, I'll make it simple. If I divide f of x by the divisor in this case is x minus b, right? Where b is a number like 2, or b could be negative as well. For example, if you divide by x plus 3, then b is minus 3. It's x minus minus 3. So that adjustment you can do between positive and negative. Then the remainder is nothing but f of b. That's what the remainder theorem is telling us. Okay. And the factor theorem is just a special case. The factor theorem is saying, if f of b is 0, then x minus b is a factor of f of x. That's very obvious, right? If f of b is 0, what do you mean? It's saying the remainder is 0. When you say remainder is 0, that means what is exactly divides, which means it's a factor. So remainder theorem is not adding too much extra value. Sorry, the factor theorem is not adding too much extra value. It's just a special case of a remainder and saying if such a remainder happens to be 0, then it's exactly divisible. X minus b is a factor of f of x. Is this clear, all of you? Okay, let's practice 1 or 2 questions and then it'll become clearer. Let's get something here. Sorry, my kids installed some random things in my computer and then I struggle. Um, okay, let's do the B part. Can we do 3B? Find A. Sarah, you have something?
Not yet, almost.
Okay. Okay, Dave, what's your answer?
I got AS2.
AS2. Okay. Anyone else get same A as in the answer to 3B? A is 2. Okay, that's what his answer is. Anyone matches his answer?
Same.
Same, right? Okay, yeah. So we are putting f of -1 because x plus 1. So f of -1 will be 2 times -1 plus -1 square. A times -1 minus 5 equal to -8. And then you can solve and get A equal to 2. Okay, so fairly easy. Let's do one more or two more. Okay, can we do this one? Z plus, you understand, right? Z plus is positive integers. Z is integers. Z plus is positive integers. Okay, Sumer, you have something?
So I've figured out A. I'm just gonna figure out N.
Okay. Yeah, anyone with N yet? Avia? You have N?
Just 1 sec, so I think I'm almost got it.
So I got A as -3 and N as 1/4.
I think n should be 4. Let's I did it quickly. Let's okay. So A is -3, we all agree. And then the second part is
Even
f
I
of
got N as 4 only.
4, right? So f of -3 is 129. So same thing. So 2 times -3 power n plus A we know is -3 times -3 whole square, right? -6 equal to 129. So this is -3 times 9, which is -27. So -33. So it goes to the right as +33. And then the divide by 2 is -3 power 4. And this I think is 81, if I recall, right? If I do it correctly.
Yeah.
So, and then therefore n is not 4. I mean, n is not inferred here, but at this step we can infer that it's 4. Okay. So we'll get this. And this is in fact an easier problem where you can find A first and then find B, then find N. There could be cases where you have to simultaneously solve the two variables. Some of the homework problems will have that nature. All right. So that's the remainder theorem and factor theorem. What did I want to cover next? Wanted to cover sum of roots and product of roots. Right. So in quadratic, you have seen this sum of roots, product of roots. So if I have ax square plus bx plus c equal to 0, then the sum is -b by a and the product is c by a. Okay. Now, you can apply the sum and product concept to higher orders as well. Suppose I have ax cubed plus bx square plus cx plus d. Okay. So now the sum, I'll put S1 here. Okay. S1 is -b by a. The first sum is -b by a. What do you mean by the first sum? Okay. So let's say alpha, beta, and gamma are the roots of this. Right? Just like in this case, for the quadratic, we have alpha and beta are the roots. So these are the roots. So for a cubic, there'll be 3 roots. So these are the roots, alpha, beta, and gamma. Okay, so the S1 is the sum of the roots taken one at a time. What do you mean taken one at a time? When you do 2 at a time, you'll understand what 1 at a time means. Now, if I instead I do alpha beta plus beta gamma plus gamma alpha. Right? It's a product. It's a sum of the product of roots taken 2 at a time. So that's called S2 because you're taking 2 at a time. So that will be C by A. So it'll alternate between minus and plus. And S3, which will be the sum of the product of roots taken 3 at a time. When you take 3 at a time, it's just alpha, beta, gamma. That's the only way of taking 3 at a time. So that's the only term. So this extreme one is the pure product, right? And the first one is the pure sum, the normal sum as we all know. So that's the real sum. And this is the real product. In case of quadratic, there's not much because there are only 2 roots anyway, right? Taken 1 at a time was just alpha plus beta. Taken 2 at a time was just alpha beta. So this was S1 and this was S2. There was only 2 sums. Now, if you go for fourth, it'll become even more clearer, right? So suppose the same thing. Okay, I'll write it where I have to clear more space, right? Okay, so suppose I have ax power 4 plus bx cubed plus cx square plus dx plus e. And this e is just the normal e, not the mathematical constant e. Okay, so and this will have 4 roots: alpha, beta, gamma, and delta. Typically, roots are denoted as Greek letters. So S1, which is the sum of the product of roots taken 1 at a time. If you're taking 1 at a time, there's no product at all. It's the pure sum, right? So it's just alpha plus beta plus gamma plus delta. So that will start with minus b by a. It will always start with negative of the penultimate upon the ultimate. S2 will be sum of product of roots taken 2 at a time. So that'll have the combinations alpha, beta. Let's finish all the alphas first. Alpha, beta, alpha, gamma plus alpha, delta. Now we'll go to beta plus beta, gamma plus beta, delta. And then we'll go to gamma plus gamma, delta. So no surprises. There are 6 terms in this because of the 4 roots, you're choosing 2. So how many ways can you form a group of 2? It's 4 choose 2, which we already studied, right? 4 into 3 by 2 into 1, which is 6. Hence 6 terms here, alpha, right? There are 6 terms here. So this is your plus C by A, right? Minus B by A, now plus C by A. The third one is S3, which is sum of product of roots taken 3 at a time. So we know 4 choose 3 is 4. So of 4, suppose you have to pick 3, what would you do? You would eliminate 1. Eliminating 1 is same as choosing 3, right? So in the first one, I'll eliminate delta, so alpha, beta, gamma. In the second one, I'll eliminate gamma, let's say, alpha, beta, delta. In the third one, I'll eliminate beta, so it'll be alpha, gamma, delta. In the fourth one, I'll eliminate alpha, so beta, gamma, delta. So there are 4 of them, no surprises. So this S3 taken sum of product of roots taken 3 at a time. So this sum would become minus D by A. And then lastly, sum of product of roots taken 4 at a time. There's only one way to take 4 at a time, alpha, beta, gamma, delta, which is the pure product. So this is the pure product, and the very first one is the pure sum. Okay, so this will become E by A. Notice that it alternates between plus and minus, plus and minus, plus and minus. Okay, so that concept will come in handy, sum and product of roots. Let me see whether I can pull up some questions on these. Sum and product of roots. Mm. Okay, yeah, this is a good one. I can do this one. Okay, can you do this? X plus 3 and 2x minus 1 are factors of this guy. Zeros means roots, right? So zeros, roots, solutions all mean same thing. They're all synonymous. Okay, Dave, question? Yeah.
The factors means that when you like you put this and after that the remainder will be 0, right? That's what
Correct. That's what the factor theorem is saying. Correct. Yes. So f of minus 3 is 0. Hence, the
Yeah.
remainder is 0. Hence, x plus 3 is a factor. Quartic means 4th order. So we have quadratic, cubic, and then quartic. So x power 4 is the highest. So something a x power 4. So no, not this a. I'll just say some p x power 4. So in this case, p is 2. But p does not matter. P is just a coefficient, x power 4. And zeros of the quartic, what the hidden word here is quartic equation. Right? If you set this equation, set this expression to be equal to 0, such an equation, 4 zeros or 4 roots or 4 solutions. Using that, he wants to find A and B. Are A and B solved? Amit, do you have A and B? Amit, are you around? Dave, do you have A and B?
No, I've created a simultaneous equation and to solve.
Okay, all right. If anyone has A and B, please call out so that others can also verify before proceeding further. I'll also, you don't have to look at my solution here, but I'll also silently do it here.
I've got A and B.
Call it out, please.
So A is 1 and B is minus 15.
Okay, all right. If anyone gets the same answer, that's good. It'll be consistent. Please proceed, Adya, meanwhile. At least it seems to satisfy the first equation I have here. So please proceed. If anyone is stuck, you can look at the board, guys. Yeah, I got the same thing, Avya. B is minus 15 and A is 1. That's good. Okay, and then how do we proceed from here, guys?
So we can just do minus B by. We can
Okay.
get the sum of the root.
Yeah.
But I don't know.
Okay, so 2x power 4. Okay, I'm assuming all of you got this A and B. So I'll replace A and B as follows. So minus 15 for B, minus 15x squared plus A is 1. So x plus 3. Now this is the quartic equation. Now this guy has 4 roots. So 2 roots are known. One root is minus 3 and one root is half. That's why they are factors, right? So when set it equal to 0, 2 roots are minus 3 and half. Okay, so the 4 roots are, let's say, minus 3, half. Let's say that other 2 roots are P and Q. These are the 4 roots. Okay, so I can use, there are multiple ways of solving this. Okay, so one way, let's forget the sum of roots, product of roots for a second. We can verify that later. Very simply, how would I do if I didn't know the sum of roots and product of roots? I will divide this by the quadratic. What quadratic? We know that x plus 3 is a factor, right? Was it x plus 3? Yeah, x plus 3 and 2x minus 1. So let me multiply with x plus 3 times 2x minus 1. So I have 2x square plus 6x minus x minus 3. So it's 2x square plus 5x minus 3. Right? 2x square plus 5x, right? Yeah, 5x minus 3. So let me divide this by 2x square plus 5x minus 3. Okay, so in this case, I'll have to do the long division. Okay, so let's erase this X space. Okay, so I have 2x square here because, sorry, 1x square. Only 1x square, right? So x square times 2x square is 2x power 4 plus 5x cube. Okay, so I can subtract 5x cube. Then minus 4x square divided by 2x square is minus 2x. So minus 4x cubed here. And then the minus 2x when multiplied by the plus 5x gives minus 10x square. I subtract. So minus 5x square plus x. So minus 5x square upon 2 is minus 5 by 2. Right? So minus 5 by 2 times 2 is minus 5. Just watch out if I'm doing some mistake, please call out, guys. I already have a hunch I'm done something wrong because it doesn't seem to match exactly. Or is it? I'm not sure. Let's see. Yeah, it doesn't seem to match, right? 2x minus 1, 2x, 6x, 5x, 3. Oh, when I multiplied, I didn't multiply throughout, right? I multiplied only 2 terms. In the first step, when x square multiplies, it gets 2x power 4 and then 5x cubed, and then I forgot the minus 3x square. So what comes here is minus 4x cubed, minus 4x cubed, minus 12x square. Okay, and then I'll bring the x alone here. Okay. So in the next step, it will be minus 2x. So minus 4x cubed minus 10x, right? Is it 10x square? And then minus plus 6x. Okay. How much is this? Minus 2x square minus 5x plus 3. And then when I multiply this one with plus minus 1, I guess. So it becomes minus 2x square minus 5x plus 3. So no surprises, it's matching exactly 0. So one quadratic was 2x square plus 5x minus 3. The other quadratic was x square minus 2x minus 1. So in other words, this quartic was the product of 2x square plus 5x minus 3, which is nothing but the product of the two factors that we already had, x plus 3 and 2x minus 1. The other quadratic is x square minus 2x minus 1. Okay. Now, how do you find the other two roots? This quadratic is already solved, right? That's how we found x equal to minus 3 and x equal to half. Those were given to be already roots. The other quadratic is what we have to solve. That we can just use the regular quadratic formula and solve the roots of this. The roots of this are the p and q that we are seeking. So the roots of this are the p and q that we're seeking, which is minus b plus or minus root of b square minus 4ac will become plus 4. 4 into minus 1, right? And then upon 2a. So it's 2 plus or minus root 8 upon 2. And 8 can be written as 4 into 2. So the 4 can come out as a 2. So it's 2 root 2 upon 2. So which is 1 plus or minus root 2. So in other words, the 4 roots of the entire quartic are minus 3, half, 1 plus root 2, and 1 minus root 2.
So
Yes.
is there a faster way to do this?
Yes, please. Go ahead.
No, I'm asking you some.
No, I was just doing a silly mistake, which is why it took a little longer. But the faster method, you have to divide the quartic by the quadratic, arrive at another quadratic and solve it. right? There is another way, which is the sum of roots, product of roots, which I'm going to do, but more or less it will work out to be the same speed. Let's do that also. Is this clear so far, guys? How we did this? Okay, now that we learned sum of roots and product of roots, just imagine that we have not done this division, right? I only know that the roots are p and q with -3 and -3 and plus half, and I'm searching for the p and q. So let me do the sum and product of roots. So the very pure sum would be p plus q -3 plus half. That's the sum of the 4 roots. And that is minus b by a. So -1 by 2. -1 by 2. So how much is that? So p plus q, if I can simplify, how much is this? Minus 2.5 plus 2.2, right? So I know p plus q is 2. Okay, and now I can use the product of roots, the plain product of roots. So minus b by a, c by a, minus d by a, e by a. So the product of roots will be 3 by 2, right? And what is that product? 3 by 2 is the product of -3, half, p, and q, right? That's a pure product, the extreme ends. So 3 by 2 gets cancelled with 3 by 2, leaving pq is -1. So in other words, we have to find two numbers that add up to 2 and multiply to -1, which we cannot easily guess, which is why the roots that we got were random, like this 1 plus root 2 and 1 minus root 2, right? So how do we solve them? Assuming we don't know this 1 plus root 2 and 1 minus root 2, we'll do the normal process. So I'll replace q k jagame, I'll replace it with -1 by q, -1 by p, right? So from this, I know q is -1 by p. I'll replace q as -1 by p here. And then you'll see I'll get the same quadratic if I multiply throughout by p, right? And get the 2p to this side. It's p square minus 2p minus 1 equal to 0. And then solve this, right? And when you solve, if you see, it's the same quadratic that we solved earlier. We got x square minus 2x minus 1, right? Exact same quadratic. It's instead of x, it's p. That's the only difference. So we'll solve p is minus b plus or minus root of b square minus 4ac. Same thing, whole upon 2a. And we'll arrive at 1 plus or minus root 2 as p. And q equivalently has to be the reverse, right? If p is 1 plus root 2, q has to be 1 minus root 2, so that the sum adds up to 2, because we want p and q to add up to 2, right? And similarly, if p is 1 minus root 2, the other on q will be 1 plus root 2. So in other words, p and q between them are 1 plus root 2 and 1 minus root 2, in whichever order, doesn't matter. Does that make sense? Okay, and let's also use this sum and product of roots just for verification. Let's see whether we are able to get the -15, even though that's not even asked. So what is the -15 supposed to be? The sum of the product of roots taken 2 at a time. Okay, so let's verify that. Let's verify that. We are just going to verify, that's it, right? So now that I know the roots are these, so sum of product of roots taken 2 at a time. So it might seem a bit messy, but so there are 6 terms, right? So it's -3 into half. So these are the 4 roots here. Okay. So -3 into half, and then -3 into 1 plus root 2, and then -3 into 1 minus root 2. Okay. Now, and then plus half into 1 plus root 2, plus half into 1 minus root 2. And then lastly, 1 plus root 2 times 1 minus root 2. So let's do this entire thing, right? Each of them can be simplified, right? So this one, I'm not going to do -3, 1 plus root 2, -3, 1 minus root 2, because the root 2 will get anyway cancelled. So -3 into 1 and -3 into 1 will be prevailing. The root 2 will get cancelled anyway. So it's -6 and then -3 by 2, right? So -6 -3 by 2, -15 by 2. Okay, here same thing. The half root 2 and the half minus root 2 will get cancelled. So half plus half will prevail. So it will be +1. And here it's a plus b times a minus b, which is a square minus b square, which is 1 minus 2, which is -1. So ultimately, what do I have when I combine all of this? 1, 1, and 2 get cancelled. So leaving -15 by 2. Is that matching with my expectation? I'm expecting sum of product of roots taken 2 at a time to be c by a. We started with -b by a as S1. C by A is S2, the sum of product of fruits taken 2 at a time. Does this match what I have? Yes, C by A is minus 15 upon 2 indeed. Right? So it does match. So everything is consistent. Thais, you're with me completely on this? All good?
Yes.
Okay. Cool. Anyone, any doubts? Dave, all good? Sarah? Okay. Avya, you're on video off. All okay?
Yes, sir. So someone's in my room.
Okay. Cool. So we did sum of fruits, product of fruits. Okay, let's go to transformations. That's an important thing, right? That's so transformations of functions. Right. So there are 3 different types of transformations. The first one is translation, right? Also known as shifting. Okay. And then there is stretching or shrinking. Stretching or shrinking. Right? Shrinking, okay, with an I. Okay, and then lastly, there's reflection. So we'll look at each of them. Okay. So what is translation? So let's take one example, right? So suppose I have y equal to 2x plus 7. This is the function f of x, right? Whatever operation I do after evaluating f of x will correspond to an operation on y. Okay, by that, what do I mean? If I have f of x plus 3, right? That's a translation. So, okay, in fact, I will put, okay, I'll give an example here itself, right? So I'll move this here. Okay, so I said y equal to 2x plus what I forgot what I said, 2x plus whatever, doesn't matter, right? So let's say 2x plus 5. That's your y equal to 2x plus 5. Now that this is your f of x, your initial f of x. Now if you do f of x plus 2, that's translating up by 2 or shifting up by 2, right? So this is an operation on n, operation on y, operation vertically, right? So this is getting shifted up by 2. On the other hand, suppose I do 3 times f of x, it's getting stretched up by a factor of 3, right? So you're pulling it upwards by a factor of 3, right? Which means positives will become more positive, negatives value will become more negative, right? So for example, if I have this 2x plus 5, how will this graph 2x plus 5 look like? So 2x plus 5 will be something like this, right? So let's say it's like this, right? Right now, this will become pulled up by a factor of 3, meaning whatever is on the origin, so whatever is on the x-axis won't have any effect, but everything positive will get pulled up by a factor of 3. So every point, so this, right, every point is getting pulled up by 3. Similarly, on the negative side, I mean, this is supposed to go through this point, right? So I messed around this point. Just imagine this is the meeting point, right? So every point is getting pulled up. So this point is getting pulled up by a factor of 3. That's what 3 times f of x does, right? And this point is also getting pulled up by 3, but because it's negative, it's becoming more negative, right? But the main thing to notice, it's vertically getting stretched, right? And similarly, the f of x plus 2, right? So what was happening here? So the normal f of x was like this, let's say. Then f of x plus 2 would be uniformly moving it up by plus 2, plus 2, plus 2, plus 2. So shifting up, translating up by plus 2. So both of these examples are clear, right? Let me just erase this, make space. Okay, and reflection. Reflection is, suppose I have minus of f of x. That means the entire graph gets reflected vertically, meaning gets reflected along the x-axis, around the right, gets reflected vertically. So whatever is like this now becomes like this. If this is the x-axis, right? It gets reflected. Just imagine it's like a pond, right? And then it's getting reflected around the pond. So it's getting vertically reflected, right? Now, equivalently, we have operations operating horizontally. Okay, now here you have to be a little careful. So suppose I have f of x minus 3. It actually means it's shifting right by 3. So for y, for the vertical operation, it's very easy. Plus means upwards, minus means downwards. That was very easy, right? Intuitive, it was very intuitive. Here in x, it won't be intuitive, and you'll understand why later. But for now, just take it for granted. If I'm having with f of x, if I'm constructing a new function f of x minus 3, that's shifting right by 3. So this is shift right by 3. Shift right by 3. And conversely, if I have f of x plus 7, it's shifting left by 7. Okay. Now, similarly, if I have f of 2x, right, it is horizontal, it's not stretch, but horizontal shrink by a 2, right? So it's horizontal shrink by 2, but we always look at it as a stretch factor. So we'll say horizontal shrink by 2, not stretch. Shrink, huh? I always ignore the end. Horizontal shrink by 2, or equivalently, you can say stretch by 1/2. Meaning what? The graph has compressed. It's become narrower. If f of x is in a certain shape, f of 2x has become narrower. Okay, we'll understand all of this when I share the GeoGebra. We can do it there, right? F of 2x, contrary to what your intuition might say, f of 2x is not a stretching, but shrinking by a factor of 2. Okay, and the last one is fairly easy. That's intuitive. So it's f of minus x, right? F of minus x is just reflecting horizontally, meaning whatever is on the right has come to the left. That's very easy. There's no intuition there. So f of minus x is reflecting along the vertical, reflecting about the y-axis, or it's rather it's a horizontal reflection. What's right has come to the left, right? Just like minus f of x was a vertical reflection. What is up has come down. What is down has come up. Okay. Now let's understand each of them, right? I will. Okay, let's take one function, right? So let's take one simple function. Let's operate on this function, x square plus 5x minus 6. Okay, fine. Let's take x square plus 5x minus 6. Would that be okay? Yeah, that should be fine. So let me just bring up GeoGebra and let's share screen, right? Okay, are you guys able to see this GeoGebra? Okay, so I said x square. Sumer, can you read out what I said? Plus, was it plus 5x? What is the problem I made? Plus 5x minus 6, was it?
I think so. I didn't note it down, sir.
Oh, okay. Yeah, it's there here, right? X square plus 5x minus 6. Okay, right. So no surprises. The two roots are minus 6 and 1. Are you able to see my GeoGebra, right? You
Yes.
see,
Yes,
okay,
sir.
and you're able to see my notebook as well, right? I'm sharing my entire screen, so you're seeing this, right? So this is the green graph. Now let's do step by step. The first one we'll do is the shifting up by 2, right? F of x plus 2. So in other words, it'll be just x square plus 5x minus 6. This is the original equation. If I just do a plus 2, right? Or maybe I'll just illustrate plus 10 so that it's easy. So every point has shifted up by 10. right? So it might seem like the points here have shifted more. It's not the case. It's just that the values are much higher here. Are you able to see my mouse also move?
Yes, sir.
Okay. So it's not like the gap is narrow here. The gap is narrow here if you look at it in a particular angle. If you look at vertically, every point is getting shifted up by 10 uniformly. So shifting up by 10, that's very easy to understand. And conversely, if I shift it down by 10, that's also easy to understand, right? That's the blue. Okay. All right. Plus 4, let's say. Okay. It's shifting up by 4. Now, the second one that we wanted to see was 3 times f of x. So what I'll do is I'll put 3 times. Is there a way to copy this? Okay, all right. Okay, 3 times. I'll just literally write this. I don't know how to copy this. X square plus 5x minus 6. Okay, I'll delete this, otherwise it'll be too confusing. Or is there a way to? Okay, right. So this is a stretch, the vertical stretch by a factor of 3. So every point has gotten stretched by a factor of 3, right? Had it been little stouter, I could have seen this. Is there a way to set the, are you guys able to see this, right? Vertical stretch. So you can see that different points are getting stretched by different quantities, but the factor is always 3 times. And therefore, whatever is in origin stays at origin. And whatever is negative has gotten more negative. So it's a vertical stretch. Okay. Now, and the last one is reflection, minus of f of x. So here, I'll just replace the 3 with minus sign. Okay. So that's this reflection, vertical reflection. Whatever is up has come down, whatever is down has come up. Okay, does it make sense, all of them? So that's the Thais. I'll ask you, is this all okay, consistent, the operation vertically?
Yes, sir.
Okay, all right, now let's do the horizontal. So now every x, so I'm looking at f of x minus 3. F of x minus 3 means what? Every x gets replaced with x minus 3. So here, instead of x square, I'm going to call it x minus 3 whole square. And so instead of this 5 times x, every x gets replaced with x minus 3. That's what the meaning of f of x minus 3 is, right? Okay, so it's 5 times x minus 3, and then the minus 6. Oh my God, what happened? Shit. Okay, all right, I have to redo this. Okay, so x minus 3 whole square plus 5 times x minus 3 minus 6. Okay, so you see the green was the original one. You can see the green for f and then the red for the h of x here, right? He has indicated which color is which. So the green is to the left, right? And the red is shifted to the right. So, or rather, green is the original one. Now the red one is shifted right, even though it's f of x minus 3. Right, Sarah, are you clear? This is getting shifted right?
Yes, sir.
Entire graph should be shifted right. Okay, so that's the horizontal translation, horizontal shifting. Now we'll do the shrinking, horizontal shrink by a factor of 2. So which means what? If I replace every x by x into 2. So instead of x, it's 2x. That's what f of 2x means, right? And instead of x, instead of 5 times x was the original one, I'll make it 5 times 2x. And then the minus 6 as it is. Now this one, the original one was the green one, right? Now you can see that it's shrunk horizontally. It's shrunk horizontally. Are you able to see this? Right? So on the x-axis, maybe I'll just zoom in a little bit here, right? Right? The original roots were minus 6 and 1. Now it's shrunk by a factor of 2. The new roots have become minus 3, which is half of minus 6, and half, which is half of 1. So the red one is the shrunk version. On the other hand, suppose I replace every x with x by 3, it will stretch by a factor of 3. So it's counterintuitive. Okay, so here it's stretched by a factor of 3. The red one is the stretch. Instead of the roots being 6 and minus 1, now they become 18 and minus 3. 18 and plus 3. Yeah. So, okay. So that's the stretch, right? We say this is a stretch by a factor of 3, right? And similarly, in the earlier one, we don't say it's shrink. We can say it's shrinking by 2, but we consistently use the word stretch. We say it's horizontal stretch by a factor of 3 in this case. And the previous one where it's actually shrunk, instead of saying it's shrunk by a factor of 2, we'll say it's stretched by a factor of half. Okay, that's the normal convention. So even though it might be little difficult to visualize, shrinking by 2 is easy to visualize, right? Stretching by a factor of half is not easy to visualize, but that's how you're formally supposed to write. Stretch by a factor of half. Okay, and then reflection is fairly easy. The reflection is every x is getting replaced with minus x, right? So in this case, right, every x is getting replaced with minus x. So minus x whole square, anyway, it's x square only, but I'll just follow the rules, right? Every x is going to get replaced with minus x. That's what I know. And therefore, that's exactly what I'll do. Every x is getting replaced with minus x. And then the 6 is this, right? So this is a reflection along the horizontal direction. What is right has come to the left. What is left has gone to the right. It's a reflection about the y-axis. Horizontal reflection. Horizontal reflection is about the y-axis. Vertical reflection is about the x-axis. Okay, is this clear, guys? Completely, all of this?
Yes.
Okay, already. Please experiment. If you experiment, you'll learn a lot more, right? Rather than me telling. Okay, all right. Now we can do a series of these also. So by that, what do I mean? So if I have y, sorry, did I stop my sharing completely? Sorry. Sorry, I'm seeing some chats only late. Amit, you had chatted me something earlier, or was this answers to the previous question?
Yeah, I did.
Sorry. Just please call out. I'm not actively paying attention to the chats. If I don't
All right.
respond in, let's say, 30 seconds or 1 minute, very likely I've not seen the chat. Just call it out, please. I'm sorry, I missed it. But it's moot at this point, right, Amit?
Yeah.
Okay, all right. So suppose I have y equal to sine of 3x. Okay, and suppose I want to go through a series of transformations. This is my f of x, right? And my destination is minus 5 sine minus 12x plus 60 degrees plus 2, something like this, right? I want to start with sine 3x and I want to arrive through a series of transformations here. Okay, so let's do this. There's no one answer, there's multiple answers. We'll discuss at least 1 or 2 so that you know that you can appreciate that there are multiple ways. Why am I not able to click this? Okay, all right. So the question is clear, right? So we want to go from the original f of x through a series of translations, right? Now, first thing I can do, instead of sine 3x through, okay, in fact, I'll ask you this. What should I do to make it sine 12x? Let's see, Sarah, what should I do? You should, for example, an answer could be a vertical shift by a factor of 3, something like that, right? Obviously, that's a bogus answer. So your answer should be something like this. Tell me. Sarah.
Okay, I'm not sure, but is it
First of all, is it, well, let's break it down. Is it a horizontal operation or a vertical operation?
horizontal?
Horizontal, because the vertical operation would be after evaluating the entire sine 3x, on top of that, you're doing something. Here, you're going inside the function itself and operating. So sine of 3x has become sine of 12x. It's horizontal. And is it a translation or is it a stretching or is it reflection?
It's a stretch.
Very good. Okay. So horizontal stretch. And what is the stretch factor?
Oh,
Sorry, louder.
4.
That's exactly the wrong answer. 1/4. It's always the opposite. Whenever it comes with x, it's always confusing, but good, right? It's not 4, but 1/4. So it's a stretch by a factor of 1/4 or rather a shrink by a factor of 4. So sine 12x is a narrower version of sine 3x. It's shrunk by a factor of 4. So stretch factor of 1/4. Yeah, makes sense, Sarah?
Yeah.
Okay. Now, Avya, sorry. Now, from here, I want you to go to sine of minus 12x. What operation?
So horizontal reflection.
Horizontal reflection. Wonderful. Yes. So it's going inside the function itself, and f of x has become f of minus x. So it's just horizontal reflection. Very nice. Okay, Amit. So from here, I want to go to sine of minus 12x plus 60. Amit, you're there?
Sorry, I didn't hear what you said.
Okay. You followed along the two transformations so far, right?
Yeah.
Now, for the last transformation from sine minus 12x, I want you to go to sine minus 12x plus 60. What transformation would you do?
It would be a shift to the left, right?
You tell me, and then we'll discuss. Shift to the left by
Sine of minus 12x to sine minus 12x plus 60, right? A shift to the left of 60 units.
shift to the left by 60 units. Okay. That's the first answer everyone gives, and that's wrong. Okay. Can you guys all think why that's wrong? It seems very fair. We discussed, right? So when we did f of x goes to f of x minus a. So we did discuss
Oh,
f of x to f of x minus a.
it's 60 degrees, right?
Yeah, 60 or 60 degrees, doesn't matter. Fine. Let's say 60. Don't worry too much
So
about the
is
degree
it a
part.
shift to the left of pi over 3?
Forget radians, degrees, and all that, right? So just imagine it's some function, right? So just focus on the number itself. Okay, so we did say that f of x goes to f of x minus a means shift right by a, right? And we said if it's f of x goes to f of x plus 3, it's shift left by 3. In fact, even the a, I'll replace it with a number so that it's easy, right? So if we have f of x minus 2, we did say it's shift right by 2. F of x plus 3, we did say shift left by 3. So why am I saying this is not shift left by 60 then? Anyone? Sumer? Okay, all right. It's a very important thing, right? So shifting right or shifting left is whatever you have to do to x to make, actually forget shifting, anything for that matter, right? Any horizontal operation is what do you do to the x to make it your next step, right? So what are we doing to the x is the question. Are we replacing x with x plus 60? No, we are not. If we did that, that would be sine of, we are right now in this step, right? If we did replace every x with x plus 60, that would be 12 times x is getting replaced with x plus 60. This, what I've written here is shifting left by 60, which is clearly not what we want. This is not what we want. What we do want is sine of, we can back work, we want this to mimic, right, x plus 60, right? Minus 12x plus 60 is got by replacing x with x minus 5. Are you guys with me? Okay, and therefore it's shift right by 5. Not shift left by 60, but shift right by 5. Is this clear? Thais, are you with me? Is everyone with me? Okay, this is a very subtle point, all of you, right? So, okay, so this is wrong, this is right. So right now I'm here, right? I'll erase this portion. I'll erase this portion. So from sine of minus 12x, now I have landed in sine of minus 12 times x minus 5, which is sine of minus 12x plus 60. Okay, and now it's easy, right? So effectively, this is nothing but sine of minus 12x. Numerically, it's the same, minus 12x plus 60, but we got that by shifting right by 5. Okay, and now what do I do to do 5 times sine of minus 12x plus 60? Thai, can you answer this?
It's by stretching was it vertically?
Exactly, right? After
right.
after computing the sine of that thing, then outside of that sine function, you're pulling it up by 5. So it's a vertical stretch by a factor of 5. And then the next one would be minus 5 times sine of minus 12x plus 60. Dave, what is this step?
Yeah, it would be going like vertically down, like stretch vertically down by 5 units.
No, it's just reflection, right? The 5 was already
Oh,
done,
oh. Sorry,
Right?
yeah.
right?
Wait,
It's just
so when does it like go outward? Because in all of this it goes inward because it's going up, right? So is it between -1 and 1 that it goes inward?
when you say inward, what do you mean?
Means like
Inward or
yeah,
invert?
the points going down instead of up.
Yeah, that's reflecting, right? Inverting. Is that what you mean? Invert as in reflect? Or do you mean inward? I'm not very clear. Do you mean
Inward? So like suppose if a parabola is shaping outward, if it goes inward like that, then
So if it's becoming narrower, you mean?
yeah, if it's becoming okay, so say narrow line.
Okay, that's horizontal, right? That's horizontal shrink, right? So that's what happened in the first step. It's a horizontal shrink by a factor of 4, or rather horizontal stretch by a factor of 1/4. That was the very first step, Dave, if you recall.
Okay.
If f of x has become f of 4x, that means it's a horizontal shrink by a factor of 4 or horizontal stretch by a factor of 1/4. That was the very first step which Sarah said.
Okay. Yeah.
Right now, you already have this 5 times sine minus 12x plus 60. All you had to do is replace 5 with -5, which is multiplied by -1 outside of this, right? Which means it's a vertical reflection, as simple as that. And then the last step is, Dave, can you complete it? What is the last step? Suppose minus 12x plus 60 plus the 2. Actually, who hasn't called out? Maybe Sumer. Yeah, Sumer.
It's a vertical translation, like up to.
Exactly. Vertical translation by +2 or shift it up by 2. Okay. Now, this is not the only one path by which I could have got. So for example, let me traverse through another path to arrive at the same thing, right? So I start with the same sine 3x. My destination is still same, but I can choose to travel a different path this time. So this time, what I will do is I will do sine 3x. Okay. I will go to 5 times sine 3x first. Okay, just for kicks. Okay, and then I'll do 5 times sine. Okay, so in fact, I want to do, let's say I want to do a horizontal shift. Okay, so the first step is very clear. It's a vertical stretch by a factor of 5. I've done the 5 times sine 3x. Right? I can go in any order, doesn't matter. No one is compelling me. And now, suppose I end up doing 5 times sine 3x plus 60, right? So to do this, what should I do? Effectively, this is nothing but 5 times sine of 3 times x plus 20. So the x here is getting replaced with x plus 20, right? So it's shifting left by 20. It's shifting left by 20, correct? Shifting left by 20. So this step is shift left by 20. Okay. So I have 5 times sine 3x plus 60. And now suppose I want to go from here to 5 times sine 12x plus 60, right? It's 3x plus 60 right now, but I want to do 12x plus 60. This is the same thing, right? What is this? This is what you are asking, right, Dave? Horizontal shrink by 4, right? Or stretch by factor 1/4. It's actually shrinking, But if you have to write it in terms of a stretch factor, it's stretch factor of 1/4. You're with me, Dave?
Yeah.
Okay, and now I can do every x gets replaced with minus x. So that's a reflection. I wanted minus 12x plus 60, right? That's a horizontal reflection. So the minus applies only to the x, right? Every x is getting replaced with minus x. So it's minus 12x. Therefore, it's a horizontal reflection. And now I can do, for example, again, just to illustrate multiple possibilities, I will shift down by 2, not up by 2, but down by 2. Okay, and you'll see why I'm doing this. Now, after this, I can reflect the whole thing by along vertical direction. If I reflect the whole thing upon the vertical direction, that becomes minus of this entire thing, right? Excuse me. That means it becomes minus 5 sine minus 12x plus 60 plus 2. So I can shift it down by 2 initially and then reflect, right? Just to show you different possibilities of achieving the same thing. Is this clear? Are both methods clear here? And there are multiple ways by which you can reach. There are a lot more, right? By changing the sequence. Okay, all right. I think we are done with transformations. Is there anything else I missed? If at all there's 1 or 2 topics I missed, we can do next class. I will, for the most part, we are done with functions. We did transformations. Let me just go and see what else is left. I had this at the very top, right? Partial fractions we did. Synthetic divisions we did. Remainder theorem, factor theorem we did. Transformations we did. Sum and product of fruits we did. Exponential and logarithmic functions. We didn't touch on them, but that's hardly like 5-10 minutes. We can do at the beginning of next class and we can proceed further. Okay. All right. Do the homework problems very sincerely, guys. That's the main learning. 20% of it comes in class. 80% is when you struggle and do the homework problems. Okay. So definitely do it. Okay. Giving sufficient time. Okay. Bye. See you next Saturday.
Thanks. Bye, sir.
Bye, sir. Thank you.